Greetings. Welcome to this new course on electronic packaging and manufacturing. Okay. Let me first introduce myself. My name is Anandaroop Bhattacharya and I am a faculty member in the Department of Mechanical Engineering at IIT Kharagpur. Today what we will do is, in today's lecture, on this first lecture, we are going to start with a bit of introduction and we are going to introduce this topic of electronic packaging and manufacturing. Now, what do I mean by this? What is electronic packaging and manufacturing? Okay. So, I think this term is maybe a little new to many people. You may have listened to my introduction video where I had spoken a bit about this course and what it is about, but let us first try to understand what electronic packaging is, and that is what we are going to do in this first lecture that we are going to discuss today. So, without further ado, the concepts that we are going to cover today are as follows. We will start with a little bit of information about the electronics industry today. As we all know that electronics is very omnipresent in our lives today, and we are going to talk about that what are the different kinds of electronic products that we come across in this world, and where we see electronics in the various fields, various areas, various domains in our everyday life. Followed by that, we are going to talk about electronic packaging. What is electronic packaging? Okay, so this is probably going to answer at least partially the first question about what do we mean, what is the main crux of the course that we are going to discuss. Okay. Thereafter, we are going to talk about the different levels of packaging. So, I am going to just introduce the different levels of packaging, what is first level of packaging, what is second level of packaging, and so on and so forth. But primarily in the next course of, or on the next many lectures in our course, we are going to take each of these levels of packaging one by one and study them in detail. Now, what are those details that we are going to talk about when we introduce you, when I introduce you to the different levels of packaging. And finally, what we will do as part of this introduction module is to start with the very basic first level, which is called the wafer, from where we get the silicon dies that go into our microelectronic devices. Okay. So, that is going to be the concepts of the topics that are going to be covered as part of this introduction module. Okay. So, let us move on and try to look at electronics industry. So, my friends, I hope you will all agree with me that today our life has been invaded by various electronic products. Okay. We all, probably all of us, own a mobile phone today. It's our constant companion, and that is probably the most omnipresent, the most ubiquitous electronic product that we use in our lives. Okay. And definitely a little bit advanced form of a mobile phone is a smartphone, which also many of us have today. And there, the smartphone is not just a phone anymore, as we all know. It has become our watch, it has become our camera, it has become our a device where we can listen to music, watch movies, we can record music, and so on and so forth, right? So, as we can see that the electronics industry on the whole is slowly or not slowly, over the past few decades has grown at a very rapid pace, and it is still growing at 5 to 8% year on year, if you look at the entire electronics industry, that is. Okay. Now, out of that, if you look at consumer electronics, which is where our smartphones, our laptops, our computers, tablets, or even if you talk about televisions and microwave ovens and radios, where these come into pick, the music players. So, these are all part of consumer electronics. So, out of electronics, this consumer electronics segment grows at a much faster rate. And again, we can just think about that using the example of phones. Let us say when I was growing up, for maybe 30 years back, a family would have one landline phone. Many families did not even have that. And today, if you look at it, it's not anymore that one family has one mobile phone. It's like every family member, every adult family member has one mobile phone. So that is the pace at which, if we just talk about the phones, that is the pace at which it has grown, or it has been growing. So mobile phones is one example. TVs. Okay, I still remember in my childhood, in the entire locality, very few houses would have, or very few families used to own a television. Okay, I myself used to go to a neighbor's place to watch television when there was a good football match or a cricket match, maybe the quiz show that used to come in the Doordarshan channel at that time. And then slowly one day, my family, when I was probably in the 6th standard or 5th standard, my family owned the first TV. Today, it is hard to find, especially in the middle class, or even forget upper middle class, even in middle class Indian families, I think it is very rare that a family does not own a television. They may not be watching it. For example, I hardly watch TV these days, except for sports and sometimes news, but I own a TV. Okay, anybody who sets up his house, TV has become an essential commodity. Same for music player, right? So this is the pace at which the electronics industry has really grown, and I am again talking about consumer electronics. And you think about laptops and desktops. I mean, again, every family these days, especially if you have children going to high school or college, and all of them need a laptop today. Okay, I'm just talking about just end users as in people, not even enterprises or colleges. Okay, so that is the pace at which electronics industry as a whole is growing, and particularly consumer electronics industry is growing. Okay, so electronics is influencing the way we live, right? You think about, if you just take a few seconds and think about a regular day in your life and go through the sequence of events, you will appreciate that how much electronic products have invaded our lives and how much we have become dependent on it. Okay, and why is this so? Why has electronics become so important? This is because the possibilities of turning, or possibilities of translating the theory of microelectronics into an usable product, okay, that is enormous, and people are trying out newer and newer technologies every day, different variants of electronic products. Smart watches, for example, I mean, that is probably a product that came maybe 5-6 years back, and today you see that it has you find, I don't know, hundreds or maybe thousands of variants in the market today. Okay, all with a little bit of different features. Maybe most of them are very similar to each other, but a little bit of uniqueness in each of them. Okay, and you can develop these products in a very short time span. You come up with an idea, you go to the lab, you try out, and then and if it works, if the concept works, you convert it to a product which is usable, and then you market it. Okay, compare that with an automobile, compare that with a healthcare product, which also, by the way, all of these have electronics today. But if you compare these, let's say a CT machine, a new magnetic resonance imaging machine in the healthcare industry, or a new automobile, you see that the design phase itself is probably 5 to 6 years. Okay, and the lifespan also is much larger. Okay, and the other thing that we need to take into account is the very fast pace with which technology has grown. Okay, in electronics we talk about feature size in nanometers. The way it has grown and the way the miniaturization has happened, it is unbelievable and probably unmatched in any other sector that we can think of. Maybe material science is another one, if I think about the last century, but other than that, it's electronics and hardware. Okay, and as a result, what has happened is these components, the electronic components, have also become very cheap. Okay, if you compare prices of an electronic product 10 years back versus it is today, you will see that most of the products of equivalent features have become cheaper. Okay, that is not true for most industries, by the way, right? And most of the other things, a car, for example, the price goes up, but if you think of a TV, for the same features, the price goes down. Okay, for a cell phone, the price goes down. So this is the uniqueness of electronics industry, and that is what I have captured in these bullet points and what I just described. It's a multi-trillion dollar industry today. Multi-trillion dollars, think about that, 10 to the power 9, and still growing at 5 to 8% year on year. It has really influenced our life in a big way. As I was talking about, we were talking about a few products, and this is possible because if you think, come up with an idea, the possibility of turning into a commodity product in a very short time span is large. Okay, the life cycle from the concept to a final product, the design cycle, is very, very short. And finally, the technological advancement and price erosion has enabled very high growth rate. So this is electronics industry, and therefore what I am trying to, the key message I am trying to deliver through this slide is the importance of electronic products and commodities in our lives today, and therefore why is it important, or why the subject area of this course is so important. Okay, all right. If that is clear now, and if you all appreciate the points that I have mentioned in this slide, with your kind permission, I'll move on to the next one. So what are the features of an electronic industry? It's a technology driven business. Look, in an electronic product, if you are not working on the cutting edge, if you are not talking about innovation, your product is going to go obsolete in no time. Okay, and we have seen several examples of that in the last few years, in the last decade itself. Okay, there's a continuous price erosion. You have to be competitive. If you come up with an absolutely new product, yes, you can probably charge a premium, but again your competitors are going to catch up, and so you cannot maintain that high price for a very long time, and that's where the need for innovation and coming up with the next new product becomes so important. But if you can do that, it's a high growth rate. Okay, if you think of a product that comes to the market and it becomes successful, the growth rate is just huge. Okay, because again one of them is the price comes down, and second is the desirability increase. If it's a really good product, hey, my neighbor, my friend has an iPhone, I also need to have that. Okay, that desirability comes, and that gives rise to a high growth rate. Okay, sometimes my parents and uncles, they ask, why does everybody in the family need a cell phone? What is there to talk about so much? Okay, because they are coming from a generation where just one landline phone was sufficient for the family. That itself was a luxury, right? Do we need it? That's a different story. I would say yes, I need it. Somebody else will say, well, not really, but everybody is having it, so I should also have it. Okay, but whatever it is, whatever be the reason, be it need based, be it desirability based, the growth rates in successful electronic products are very, very high, right? So there are large volumes in global markets and short life cycles. Now, why is this important? Short life cycles. This has two things. One is, of course, it is about the growth rate. We normally don't use it. We normally don't use an consumer electronics product for a very long time. I know people who change their phones every year. Okay, I think average, I would say most people change their phones every 3 to 5 years today. Do they really need to change? May or may not. I mean, probably it's not so critical, but they do change. All right, TVs, yeah, maybe that lifespan is slightly more, but still not very long. Okay, so the life cycles are very short for most consumer electronics. If you think of electronics that go to your aircraft engine, that go to your spacecrafts, that goes into your oil drilling, we are going to talk about all those. So those are definitely going to be designed for much longer lifespans. Okay, now why is this important? And this because then it gives the designer, or designer has to make a judgment that, okay, what is going to be the typical life cycle of my product, and therefore I am going to design a product so that it can survive for that expected lifespan. Trust me, nobody designs a cell phone today to last for 20 years. That's an over design. That is, if you want a cell phone to perform reliably over 20 years, that's an overkill. It will lead to added cost, it will lead to added complexity, newer materials, more what should I say, more degradation proof designs and features. Is that required? Probably not. So therefore, the life cycles of individual electronic products is very important, not just to drive the market growth and price, but also from the designer's point of view as to how reliable should my design be. Okay. So we are going to again talk about this in more details when we talk about reliability, the reliability section in our course, which we will come towards probably the second half of the course. Okay. So what I am showing over here is a mobile phone, a very sleek, nice, modern mobile phone, and what goes inside. Okay, it is a nice, usable product, a very good looking product, aesthetic product that we buy, but what goes inside are these different components, okay, on a motherboard, and which is what you see here. So this is what we are going to talk about in more and more details when we talk about electronic packaging. We are still not talked about what is electronic packaging. Still hold on, we will come to that. I am building the suspense. Okay. All right, so let's move on to the next slide and still appreciate about the presence of electronics in our lives. Okay. Major electronic systems and markets: computers and business equipment. Calculators, I believe calculators have now become, well, there are still scientific calculators that our students use here. That's the only thing they can bring to the they can bring to the exam hall. But if you ask me, I do have a calculator, but I hardly use that. If I have to do some calculations, I just take my phone out and do it there using that app. But I've still included calculators because still a sizable population use calculators. Desktops, printers, photocopiers, laptops, these are all under computers and business equipments. Okay. If you think about communication, we are talking about telephones, we are talking about fax machines, modems, networking switches. These are all under communications. These are electronic products that come under the communication sector. Clear? So we talked about computers, computing platforms, we talked about telecom. Automotive electronics. You will be surprised at how much of electronics is there in an automobile. There are thousands of sensors in an automobile. Your temperature sensor, your fuel sensor, your RPM meter, these are all electronic devices today. Okay? And now when we are talking about electric vehicles or hybrid electric vehicles, a large component of that is power electronics. We are talking about batteries in hybrid electric vehicles and electric vehicles, plug-in electric vehicles, batteries, and along with the batteries comes the battery management center, battery management system, BMS. These are all electronics, and that goes into the automotive sector. Imagine, go back 30 years or so, go back to the times of ambassadors and Fiats. There was not too much of electronics in our cars in those days, but today there is electronics everywhere. Power steering, power windows, remote locking, everything is electronics today. Okay. Consumer electronics, this is where the digital home segment comes into picture. TVs, CD players, VCRs, audio players, watches, games, the Xbox, okay, the Nintendos, these are all part of consumer electronics. Computers, by the way, are also part of consumer electronics. Computers as in the desktops, laptops, tablets, they are all part of consumer electronics. Okay. Medical and industrial systems, you may not be using it every day, but if you go to a hospital, okay, if you go to a hospital, the flat plate X-ray, the ultrasound, the MRI, the CT scanner, there is a lot of electronics in each of these systems. Not just the way they function, but on the back end, the imaging part. When you get the result, the images from your CT scan or MRI scan, there is a lot of imaging that goes on, image processing using computers, computing power microprocessors. Okay. The ultrasound handheld probe that the doctor uses has a lot of electronics, both in that probe itself as well as in the station, the base station that we call it, which is connected with the wire. And today actually we are going towards wireless probe as well, which actually moves a lot of the electronics from the base station to the handheld device of the ultrasound scanner. Industrial systems. So this is the age where today one of the most hot topics is industrial automation, Industry 4.0. Okay. When you automate, there is a lot of electronics that you need to have, because primarily driven by sensors and feedback control. Okay. Military electronics, very, very important field. These are electronic products that are supposed to survive and operate in what we call very harsh environments. It's in a war zone, outdoor applications, missiles, radars, fire control systems, communications in the military. Okay, the communication systems, the satellite phones. These are the military electronics are examples of high-end electronics which operate at very harsh conditions. There is a whole segment in electronics that we call design of electronics for hot and harsh environments. Along with military, you can also think of aviation, both military aviation as well as civil aviation. Okay, our aeroplanes have a lot of electronics. I think most of them, the controls are all about electronics, right? And what else? Yeah, deep sea drilling, deep sea or even terrestrial drilling. When we are trying to extract oil or natural gas, you won't imagine how much of research on electronic products and sensors and reliable operation of such electronic products under those downhole conditions or deep sea conditions, how important they are, underwater conditions. Okay, so look at this gamut of domains where electronics have become so important, starting right from computers, consumer electronics, to communication, to automobiles, to medical devices, to aviation systems, to army or military systems. Okay, these are some of the main examples, right? So that is what is shown in this nicely over here. This is from a picture from the book by Professor Rao Tumala. It's called Microelectronics Packaging, and you see the different. If I come here and try to point over here, sorry. So look at some of these. Telecom we talked about, medical we spoke about, aerospace, that is what aviation we were talking about, automotive, consumers, computers. Think about it. Other than that, storage, magnetic storage, display, batteries. Okay. And along with all that, of course, this is a tree, this is an ecosystem. Today we are talking about Internet of Things, right? Where every device communicates with each other. There is a lot of data sharing, and along with that comes, of course, very importantly, security of that data. But when you talk about this IoT revolution that is going on today, where we are becoming so important on not just electronic products, but also the way these products can communicate and exchange information with each other, this understanding this entire ecosystem becomes very, very important. Okay, and so central to that is what you see here is a communication. If this ecosystem is represented by this tree, the communication happens because through the softwares, applications, and services. So along with this growth in the electronics sector, the hardware sector, there is also a demand, or this has also led, or side by side, there is a complementary growth or demand for better software, better services, better networking, so on and so forth. Okay. So, we are still talking about electronics segment on the whole and trying to appreciate how important and how omnipresent it has become in our lives today. Okay. So, let us move on and try to see in the next phase. Now, if you talk about an electronic product, central to that is its functioning. It has got some features, it has got some expected functions. A laptop is supposed to do some functions. Okay. The MRI machine in the hospital is supposed to do something, it is supposed to capture images. Okay. So, what is the main product, what is the main component, what is the brain of each of these electronic products? And that is where the most important component in any electronic system or device or product is the microchip or the microelectronic chip that has got integrated circuits inside. These are typically made of silicon, that is still the most common and most popular element of which electronic device or microelectronic integrated circuits are made. And inside the silicon, when we talk about integrated circuits, we are talking about the various transistors and diodes and this and that and all of these other things are. Okay. So, these are the various features that goes into a silicon microchip. Okay. So, again one thing I want to just mention at this point, microprocessor, microchip, chip, semiconductor, these are all going to be, these terms are going to be probably used a lot in this course and used interchangeably. The die, okay. So, die, microchip, IC, the semiconductor, these are all going to be used interchangeably. So, I'll try to spell them out as much as possible, but in some case if I am using them parallelly or I am using these different terms, rest assured that or please be assured that unless otherwise stated, they all mean this silicon device with integrated circuits inside. Okay. All right. So, main element in an electronic product is the microchip with the integrated circuit. Okay. But along with that integrated circuit, which is a piece of silicon with transistors primarily inside, you have memory, on-chip memory, and so on and so forth. You also need many other components in that system. Okay. There are mechanical components as well, switches, connectors, cables, jumpers. These are all form part of packaging. We are going to talk about them. There are cooling components because your product has to operate within a maximum allowable temperature. So, the heat has to be dissipated. There are storage devices. You know about hard disk, you know about solid state memory, that is over there in our electronic products, especially the computing platforms. Batteries and power supplies are required, especially in mobile or handheld products, and display components. Okay, these are some of the examples. I mean, this is not an exhaustive list, but what I am trying to say is, apart from the integrated circuit where a lot of research goes on, the VLSI design, the very large scale integration, the architecture, that what is called the microcircuit architecture or microelectronic architecture that goes into your microelectronic device, an electronic product, the final product, the usable product that we use, also has a variety of other components present inside. Okay. And all these have to work in perfect harmony to give a good user experience to the final user. Okay. So, that is what we will end today, this introductory lecture. We are going to end here today, and in the next class we are going to pick up from here and talk about what is packaging. Okay. What does electronic packaging actually mean and what does it entail? Okay. So, thank you very much, and I will see you in the next lecture. Goodbye.